Bismillahirrahmanirrahim. This is Sobia Suhail is here. Assalamu alaikum, my dear students. Hopefully you are doing well. So I have done the unit number 2, exercise 2.3, a few parts, few questions in the previous parts. Now I will continue more parts. Which parts are similar? I will skip that one. You can try by your own. Okay. Question number 5 is written as, so we can say let y is equals to x minus 5 and 3 minus 6. I suggest that this is so easy that change this into one polynomial, or you can apply the product rule also. So 3x minus x square minus 15 minus minus plus 5x. So these are the like terms, solve them together. 8x minus x square minus 15, this is y. Now dy by dx apply on both sides, derivative of the given polynomial with respect to x. So derivative of this, 8 is a coefficient, it will remain outside. Derivative of the function is x minus derivative of x square, and constant number derivative always equals to 0. 8. Derivative of x will become 1. Derivative of x square, we will use power rule. Power in start, power minus 1, and the derivative of x will be 1. 8 minus 2x is its final answer for the derivative of the given function. Next is question number 6. I will suggest that let me write the question, that use the algebraic techniques to simplify your expression as much as it is possible. Okay, when we are simplifying that, then our expression will become easier to solve, whether directly or solve by the product rule or by the quotient rule. Okay, so square, we will apply a minus b whole square formula. A square plus b square minus 2ab, as we know this before. So first term square plus second term square minus 2 times first term into second term. It's okay. Now x plus 1 over x minus 2. This will be cancelled. So 2 ones are 2 will be left. Using the differentiation, before that we can write it in the linear form. So I can write it like this. Now I can differentiate with respect to x, because x variable involved here. D by dx on this statement. Yeah. Derivative of the first function 1. Derivative of the second function, no, use the power rule. Minus 1 in start, minus 1 power minus 1, and the derivative of this function x 0. Good. 1 minus 1, no need to write. X minus 2, this is 1, no need to write. Yeah, minus 0 also no need to write, cancel that idea of writing. 1 minus x minus 2, we can write 1 over x square. Whether you want to take the LCM or keep as it is, but the derivation is done till here. This is solved. Dy by dx, the given expression is solved like this. Okay, the next one, question number 7, and the most trickiest part of this exercise. But if you use let y is equals to, if you use a little mind to change that into simplified form, okay, then it will become easier. Mostly I tell my students that keep this thing in the mind when you are doing the differentiation. So small addition and subtraction of the simple fraction should be there in your mental calculation, and quick calculation, they must be there. Like 1 plus half, it is equals to 2 ones are 2 plus 1, 3 by 2. Fine. And 3 by 2 minus 1, obviously 1 by 2. Yes, 2 ones are 2, 3 minus 2, 1 by 2. So keep these 2 in the mind. 3 by 2 plus 1, 2 ones are 2, So 5 by 2. Quickly do the calculation. Okay. And 5 by 2 minus 1. 2 ones are 2, 5 minus 2, 3 by 2. It's okay. So these type of the small calculations should be there in your mind. So quickly you can understand, if 3 by 2 power is there, it means it is the combination of the power 1 and combination of a power 1 by 2. And 1 by 2 power is replacing the this radical sign, power 1 by 2. You must know. Okay. So here, for using the algebraic techniques, I will say that this is x minus, this is power 1 and 1 by 2. So I can separate 1 power and x 1 power 1 by 2 separately. Yes. So denominator stays same. Now I want to take x common from here. 1 plus under root x. Taking x common, here left 1. Here left x power 1 by 2. Can I write it like this? Again, yeah. Okay. Now this and this is changing into the, using the formula like a plus b and a minus b will be changing to a square minus b square. Good. So I apply the formula, this one. So a is 1 first term square minus second term square. Is that okay? What about this and this? This is x, this is x. It has power 1, it has power 1 by 2. So this is the more power. So I will write power 1. When I am taking this upward, its power will be negative. So when base is same, power can be combined. Yes, 1 minus 1 by 2. 1 square 1, square and square root, opposite so cancel, only x. And this power become 1 minus half, half. Keep this point in the mind. Don't go in the calculation. Some points should be there always fresh in your mind for the quick calculation. 1 minus half, half left. Now multiply that again inside. X 1 by 2 power multiply by 1, it stays as it is. Yeah. When this is multiplied with x, its power 1 and 1 by 2 add to give you power 1 plus 1 by 2.
2 by 3.
3 by 2.
3 by 2.
Otherwise calculate 1 plus 1 by 2. Quick calculation. 2 ones are 2 plus 1. 3 by 2. Okay. Now you can differentiate at this step. dy by dx on this. D by dx on your function. It's okay. So when we have applied that, dy by dx is equals power rule. Power in start, power minus 1. And the power of the variable will become 1. No need to write now. Yeah. Minus power in start. Sorry, I write the d. Let me cancel. X 3 by 2 minus 1. And the power of this will be 1. Means the derivative of x will be 1. 1 by 2. X power will be minus 1 by 2. Good. 3 by 2. X 3 by 2 minus 1. 1 by 2. Yes. So this is negative half. Means square root of x, it can be positive, but if we can shift it in the denominator, minus 3 by 2 and then x. Yeah, we can write it in the same form, or we can simplify it by taking the LCM, and I think no need for that one. It's done. If there is anything to prove like this, so then you need to make the formation to go to the proof. Otherwise derivation is done till here. Okay. Finally this is done, and the next part is question number 8. This is the last part I will solve in this video. Next part I will solve in the next video. Plus 1 whole square divided by x square minus 1. Now this is power, means this is a function, already have square and the square of that one. Better to make one expression. Okay, because power rule applied on this and then on this, it will make you confusing, create the confusion. Better to avoid that confusion and solve the square. A plus b whole square, a plus b whole square open as a square plus b square plus 2ab. Easily. So first term square plus second term square plus 2 times first term and
Second.
second term divided by x square minus 1, same until the numerator fully solved. This is x4 plus 1 plus 2x square divided by x square minus 1. So after that, what we will do, I will write it on the next page again, then I will start taking the differentiation on that. Derivative of y and derivative of the given expression. What was that? x4 plus 1 plus 2x square, and the denominator was
Square minus.
x square minus 1. Apply the quotient rule to solve this one. Quotient rule is saying that denominator square, okay, square of the denominator, then
Denominator
as it is,
and
derivative of numerator, this one, x4 plus 1 plus 2x square minus numerator as it is,
derivative
derivative
of
of
denominator.
denominator. I'm going in the same line because it's convenient for me. Okay. Now, x square minus 1. What is the derivative of this? We will apply the power rule. Power 4 will be written in the start
For x.
and power minus 1. Power 3. Very good. Constant term 0. No need to write. Yeah. Plus 2 2s are 4. When power is coming in the start, power is coming in the start. So 2 times 4. Power 2 minus 1, 1. It is solved. Minus
x4
x4 plus 1 plus 2x square will stay as it is. Derivative of this. Power in start 2. Power 2 minus 1, 1. No need to write. Minus 0. Denominator stays as it is. Okay. First, let's check that what can be taken common from here to make it more simplified. Okay. So 4x common. First term stay as it is. When I take 4x common, here left x square plus 1. Yeah. In this term, we can write it as it is. Yeah. Because this term is getting x square plus 1 again. So I will change this again in the square form. X square plus 1 whole square. Because we are doing only simplification now. Our differentiation is done. For the simplification, we use the normal algebraic techniques again. Okay. Means simplification, take the common factor. X square plus 1 here, x square plus 1 here. Take 1 x square plus 1 common out of these two terms. X here, x here, take x common. 4 here, 2 here, so 2 can be common. Okay. From the first term, when I take 2 common, so 2 left. X is common. This factor is common, this will left here. Okay. Minus. Out of these square, one factor is outside, one factor outside, so one factor left.
x plus 1.
X square plus 1. 2x outside, nothing left. Okay. Divided by same x square minus 1 whole square. 2x times x square plus 1, and then we will open the bracket now. 2x square minus 2 minus x square. When minus is there, internal sign will be changed.
Minus 1.
Yeah. X square minus 1. In the differentiation, please write down each and everything in a neat way so you are not confused with your own handwriting style. That is a free tip. Okay, fine. So we will solve it as 2x x square plus 1 and 2x square minus 1x square, 1x square. Minus 2 minus 1, minus 3, because integers are added up to give the same integer. If the negative integers are added up, they will give you negative integer. Positive integers are adding up to give you positive integers. So this could be the final answer. Whether you want to multiply these, you can multiply, or otherwise you can keep that as it is also. No problem for that. Until I'm solving the next part. Thank you so much. Please subscribe to my channel if you like my teaching style. Allah Hafiz.